this recording, fine. Okay, so this is Tim, Philippe, and Sébastien. They will be talking about what's new in GStreamer since the last 2 decades.
Hi, good afternoon. Thanks very much. Yeah, we'll be talking about what's new in GStreamer. It's going to be very high level, so Will can follow. And if you want all the details, you have to come to the GStreamer conference in October in Dublin. But I'll give you the dates later. All right, quick introduction. Who are we? Well, we've been hacking on GStreamer for a very long time, almost 10 years now. We just started, wanted to write a music player, and here we are. We do that for fun and for profit. Work for Centricular. What's this talk about? Quick intro, and I'm going to run through it really, really quickly because you guys probably know all that, but just in case someone thought this was a LibreOffice talk, I'll go through that. So, quick intro into GStreamer, and then just we talk about some things that happened in the last year, and may or may not be interesting from a GNOME perspective. All right, GStreamer, what is it? It's a multimedia framework. It's pipeline-based. I like to say it's a little bit like Lego. You have all these little pieces, blocks, we call them elements, and you can plug them together, and then something happens. You read something from a file, you decode it, you show it somewhere, and you can build applications as complicated as you like, as complicated as you can debug it. Let's put it like that. It's basically a set of libraries that you can use. It's a set of plugins. It's plugin based, and you can connect all that, and you can add new plugins. We ship a whole lot of plugins, but there are people who do specialized stuff who ship more plugins. So lots of options you have. We wrap other libraries as well, like FMPEG and LibAV for decoding, encoding, OpenCV for image processing, other codec libraries, so we don't invent the world from scratch, but we wrap what's good. It's open source, of course. It's LGPL2, which means you can write proprietary applications on top of it, and you can write your own plugins without having to make the code public. We try to be cross-platform, runs on Linux, embedded Linux, Android, Windows, OS X, iOS, and probably other systems as well. We provide binaries for Windows, OS X, iOS, and Android on our website. Not easy to find, but they're there. So you can write apps for your phones if you like. And we try to work on all common architectures. We have a stable G-object-based API, API and API stable, and we provide bindings to Python, etc., using G-object introspection. What is GStreamer not? It's not a media player. It's not a codec or a protocol. It's not a transcoding tool. It's not a server of any kind. But you can use GStreamer to implement all that if you want to. And many people have done that. Our goals are we try to be extendable and very flexible in design. So often we do things that are a little bit too complicated, or we have abstractions that are a little bit too abstract in order to make sure we can extend it later, add new bits when required, without breaking API compatibility. We also try to integrate with everything else that's there. If you want to use it in your browser, you should. If you want to write a Qt application, a KD application, whatever, you don't, of course, but might work. You should be able to use us anywhere. Our design doesn't impose any restrictions, which means you can only use it in GNOME and nowhere else. But you can use it everywhere. And if not, talk to us, and we can hopefully fix it. We have a very large ecosystem, both companies and developers, users involved. So it's quite easy to get help from and find stuff on Stack Overflow. All right, what happened in the last year? First of all, releases 1.4, quite old in the tooth, long in the tooth now, has been released ages ago. The latest bug fix release is 1.4.5. There will be one more bug fix release, so I think we'll call it quits. 1.6 is coming up. We're kind of preparing it now. It's taken a long time to get to 1.6. I think almost a year now. Way too long, way longer than we'd hoped, but here we are. So we're basically now trying to finish up 1.6, and hopefully we can get that out in August still. And you can help us bug fix. We'll try to bug fix a little bit after the 4 days. After that, 1.8 is the next stable release series, and we'll try to get back into a stable release cycle. So we're going to try and do 6 month releases again. So once 1.6 is out, we're going to send an email and say, these are the cutoff dates, and if you don't get your stuff in, tough luck. Hopefully we can, settle on a nice release schedule again. All right, over to Sebastian.
So the next minutes I'm just going to introduce some new features, some new things that happened, something a little bit more technical. And yeah, I guess the biggest thing for most people here is that we have much better UI toolkit integration now. For example, we have direct integration into GTK. We have GTK video sync and a GTK widget. And if you're using the latest GTK 3.16 on Newer, then you also get that with OpenGL acceleration. Basically, for media players, you can really get rid of clutter nowadays. You can just use this thing. You can even overlay stuff. You can have transparency and things like that. And I'm also going to show a little screenshot what you can do with this thing later. And for all the little details, later 16:30 in the other room, there's a talk by Matthew about the GTK integration. He can tell you all the little details. We did the same thing, well, he did, for Qt, QML video sync and QML element, so you can also do exactly the same stuff in Qt. Works on X11 and Wayland so far, but should also be portable to all the platforms we support and Qt supports. Same thing was done for OS X for co-animation. There's now a video sync and a CA layer thing that you can just somehow put into your co-animation application. And I assume at some point when GSK is ready, we are also going to provide something very similar for GSK. Just some little details still about the GTK video sync. So what you have there, how does it work? Basically, all you have to do, you create a video sync as usual in GStreamer. You can use it as usual. It's called GTK sync or GTK GL sync, depending on what exactly you use as your backend. If you're using GTK GL sync, you still have to put it into another element called a GL sync bin to wrap up all the GL operations in there. So after that, you can just use it. And if you're using something like Playbin, you can just tell Playbin, use this as the video sync to video output on this. So that's on the GStreamer side of things. Now, you're probably more interested on the GTK side of things, and here it's all super easy. All you have to do is the sync has a property, it's called widget, GObject property, and from there you can get a GTK widget. You just put it somewhere inside your application, inside your UI, and everything that is ever rendered by GStreamer to the sync ends up being in your widget. And I said it before, different to what we had before with the UI integration. Now you can do all the fancy things like CSS styling, you can overlay widgets over this, you can do transparency, everything you ever wanted to do. And if you're using new enough GTK with GL support, you also automatically get zero copy rendering with some hardware decoders. So for example, with VA API, it's all going to work, hopefully. The next thing that happened in the last year is there's a new high-level playback API called GStPlayer. It was started sometime during last GUADEC. It's still separate at this point, but it's planned to be merged sometime for 1.8. And what it allows you to do is, you want to write a media player, here's your API, it's super simple. You can write a media player in something like 5 lines of code. And nowadays it's supporting all the features, I think, that Totem would need, and it should be possible to port Totem to it and probably remove about 90% of the GStreamer integration code that it currently has. So at some point, it would be nice if someone would work on that. It should make Totem's life much, much easier. Then GStPlayer also includes some sample applications, GTK, Android, iOS, and some command line thing. And there's also a Qt QML application that is currently work in progress. Before I showed a little screenshot what's possible with the GTK sync. So this is now the GTK sync inside GStreamer, and you will see you can have such a fancy UI. It has transparency, rounded corners and stuff like that. And all this is done with plain GTK. It's not using Clutter or anything. It's just using the new CSS styling stuff. Of course, this UI doesn't look very professional. I'm not a UI designer. Someone can make this look a bit nice. Next big thing that happened is that Chrome, or better Chromium, there was a GStreamer backend released by Samsung R&D some time ago. Currently it's on GitHub, you can find it here. But plan is that this is also going to be merged into Chromium upstream. And what it does is it's using GStreamer to do the HTML5 video and audio tags. So not only in WebKit, depending on the port, you can use GStreamer or in Firefox, but now also in Chromium if you apply this patch. It's using the before mentioned GStreamer, and overall the Chromium backend is something like 10,000 lines of code. It's compared to the WebKit backend, it's super small. It's doing hardware accelerated rendering over via OpenGL. I think in WebKit you now also have that. Yeah. So let's switch to WebKit. Millions of improvements there on the GStreamer backend have happened. I saw there's no WebKit talk this year, so you just mentioned a few of them that are related to the media backend. One, I said it before, the OpenGL hardware accelerated rendering of video. I think it's not merged yet, but there's a branch somewhere. Or is it merged?
It's merged, but it's off by default. Okay. I don't know why it's off by default.
Maybe it doesn't work all the
I
time.
Yeah, I think Philip's concerned about stability.
Then the support for the media source extensions and encrypted media extensions was started. I think it's also the media source extension part is merged. The other part, the encrypted media extensions, well, basically DRM is not merged yet. So in theory, you can now use YouTube with new streaming protocols they are using there, and it should work inside WebKit. The web audio support was also improved, and what started recently, there's some WebRTC integration being done with the Open WebRTC implementation, which I'm going to talk about next. So what's WebRTC? Probably not everybody knows that yet. It's some kind of new W3C standard. Basically, it's Skype for the browser, and currently it looks like it's going to be big. Hangouts, for example, is using it already. And there are a few separate projects that are doing WebRTC things with GStreamer. There's the Current WebRTC media server. It allows you to do a fancy WebRTC application. You can do basically you have some kind of server that can do transcoding for you. You can implement things like multi-user communication things on the server side with that, so that all the users are composited and only one stream is sent out again and things like that. And most importantly, in my opinion, it includes a very nice extractable GStreamer element at this point that allows you to write WebRTC applications with GStreamer. And it's called WebRTC endpoint. So if you want to do something WebRTC related, you can just take a look at the Currento code and extract that, put it into your application. It's not ideal like this, but it works. Then sometime last year, Ericsson released Open WebRTC. It's the second WebRTC implementation out there, and it's backed by GStreamer. It's a very simple API. And yeah, in both cases, usually what is required from you as an application developer is that you somehow have to integrate with some kind of web service. If you're not doing a web application, that might be a bit annoying, but nowadays it's not that bad anymore. The GNOME platform has support for the most important technologies there. libsoup recently got support for WebSockets, so that's something that very often is used in this context, and also for JSON glib. It's quite old now, but really nice API if you ever have to do stuff with JSON. So if you want to write a WebRTC application for GNOME now, all the stuff you need is there, you just need to put it together. And related to all this, there were also many improvements to GStreamer's RTP stack. not only improvements for WebRTC, but also for all the other RTP-related use cases. So if you look for an application to write, if you are bored, if you want to start something new, I have an idea what you could do. You could write a native GNOME application for the Firefox Hello thing. So if you're using Firefox, you probably noticed recently it got this button on the sides that allows you to have video chats with other users with GStreamer and libsoup and JSON glib and stuff like that. You can now relatively easily write an application for GNOME that could also integrate with that. So if you're interested and just need some help, some pointers where to look, just talk to me. Then another thing that happened recently was already mentioned today, Pinus, or Pulse Video, not Pulse Audio. It's basically an API and service for accessing multimedia devices. It's also backed by GStreamer. It allows you to access your cameras or other video devices or streams. It's also supporting compressed streams, and it also supports audio. And basically the idea is you have one camera in your computer, but maybe you have multiple applications who want to use it. Maybe you want to have multiple at the same time. Or maybe one step further, maybe you have a sandbox application that doesn't have direct access to your hardware resources. Even then, you could provide access to your camera via Pinus. And what it provides you is some kind of dbus API for all the control things. The media processing or the media passing between the processes is happening by FD parsing. So it's using quite efficient concepts. So you shouldn't be too afraid about performance in this regard. It's going to be fast. Wim wrote it. It must be fast. He's writing good code. Then another thing, I think we are mentioning it since 2 years now, OpenGL support had again major improvements in refactorings. Also something Matthew did. He is probably going to talk a bit about that in his talk later. But the most important thing that has happened is that it's now much easier to integrate into other libraries and also into your custom OpenGL code. You notice it in WebKit, but well, it was much worse before. Now it's okay-ish, it works. But this is also what allowed us to write the GL-based GTK sync, the QML sync, the core animation sync, which allows Chrome to do the accelerated OpenGL rendering. There are some example applications that are doing GStreamer stuff via OpenGL inside SDL. So if you want to have videos in your games, you can use GStreamer. And it also has Valence support. That seems to work. I didn't try it myself. You said it works. Recently, we also got support for stereoscopic 3D video. So if you have one of these TVs and can run applications on it, or if you have just a monitor on your computer that can handle this, you can just sit in front of it with your glasses, with your 3D glasses, and watch videos in 3D. And this is also something that is going to be included in the 1.6 release. I can also continue with that slide. We now have, we also did some things on quality assurance. So one thing we did was there's now a continuous integration service based on Jenkins. It's doing builds for all the supported platforms, even for stuff like iOS, OS X, Windows. So hopefully it's catching all the build failures at some point. It's also running unit and integration tests and GStValidate on Linux. So it should also catch quite a few regressions. Then there were major improvements and new tests for GStValidate. So short, what's GStValidate is some kind of higher level GStreamer testing tool which allows you to set up complex scenarios and you can run it over, say, a collection of media files and stuff like that. So what we have here is now something, you run it on all your media files and it's going to tell you, okay, here's a bug, here's something to be fixed, and it also allows you to detect regressions. And lots of new unit tests were written, and related to that, there's a new API that makes it a bit easier, GStHarness. So if you ever have to write unit tests for GStreamer elements, take a look at that. It's it's making things a bit easier.
Right, so lots of little things happen that might be of interest. We just picked some random things out. Is that on? Yeah. So for one, we have this little thing called RTSP server. If you want to stream media, especially low latency media, RTSP is a protocol, it's a session protocol. It sets up streaming. You can stream via UDP, which is lossy, or you can stream via TCP if you involve the internet or you can't use UDP for some reason. And so far, it can only stream your streams out. So you can play something as a client if you want to stream your Raspberry Pi camera or something. It's great for little projects. We have added record support, which means you can actually now send data to the server. So you can actually send your own audio or video to it and say, well, do something with it, like record it to a file or something. So you can have can build lots of things for it. It's actually used for air traffic control apparently somewhere, where the air traffic control traffic is sent to an RTSP server and recorded or something. Then we have live audio video mixing. The thing is, we have like an audio mixer and a video mixer, and it didn't work so well if your input is live, which means like like your webcam source or RTSP streams, etc. And if you then start mixing, and one stream has a network problem or is slow or something, then everything would just stop and freeze, and it wasn't very reliable. It wasn't great. If you're interested in sort of well-defined latency, broadcasting, stuff like that, that stuff just didn't work really well. So, but we have new elements now. We have a new base class. We have a new audio mixer element. The old one was called Adder. The new one is called Audio Mixer. We have a new video mixing element called Compositor, and also a OpenGL version of that. And the base code works much better with live sources. So now you can define exactly how much latency you want everywhere, and it handles live inputs really nicely. So, that's been proven in production use, so it works quite well. That's quite nice. Lots of bugs we got rid of. iOS OS X 0 copying is supported now. Same for Android, but that's still work in progress. We need to merge it hopefully in the next cycle. Our adaptive streaming support, which is HLS and Dash, which is basically most streaming these days on the web. That works much better now. Lots of work has been done on that. We have a new element called SplitMux Sync, which solves a problem lots of people have had, which is quite annoying because you have some formats, like file formats, that save a video audio into a file, into an MP4 file or a WebM or Matroska file. The problem is you can't just, if you want to, often people want to just split their files, after every, 10 minutes or 30 minutes or 1 hour or something for whatever reason. But you can't really do that with MP4 or Matroska so easily. If you just split the files at some point, you can't play back the other file parts because you're missing all the headers and stuff like that. It just doesn't work easily like that. You could make that work, but it was quite complicated. You have to jump through hoops. But now we have this element, and it does all that for you. You just say, hey, this is my muxer. This is the, split it every whatever minutes, seconds, and then it just does everything for you. And you can play the file parts. And we also have the opposite. So you can play all these different file parts together as if they were one big file, if you want to do that. And you don't lose a single frame. And the key part there is it makes sure that your new file always starts with a key frame and things like that. So it has some logic inside to take care of all that. GStreamer editing services is a little library which is meant for editing and mixing streams, editing, overlaying. So if you think PDV, basically the timeline, it's a video editing application. GStreamer editing services is the library that powers all that. You can use it in your own projects. It used to be, we have a plugin called Gnonlin. It used to be based on that, but Gnonlin is sort of unmaintained now. It had some warts, and GStreamer editing services now has a new sort of Gnonlin inside embedded. So it's sort of put on a new technical base. They can make changes now, which that breaks ABI, which we couldn't do with the existing Gnonlin elements. So GStreamer editing services should work much better in many respects. Then we have GStreamer libav, which is a plugin suite that is a wrapper around Fmpeg or libav, which provides on a normal Linux desktop installation. It provides lots of codecs for H.264 decoding, etc. And the Fmpeg project split at some point into libav and Fmpeg. They provide the same libraries. The APIs are mostly the same, but sort of two teams have gone in different directions. Some distros used to use libav. Some distros used to ship Fmpeg. You can't have both in the same system at the same time, in the same prefix, because they have the same binary names, etc. That was a great idea. Anyway, so we've been using libav for a long time, but now Debian switched to Fmpeg, and basically all the major distros have now switched back to Fmpeg. And so we've done the same, basically. It's not our fight to, it's not our decision. We just follow where the movement is, where the distros go. It goes to Fmpeg. So we've just switched back. We've had a few issues with that. The API doesn't give us what we need for zero copy performance, but hopefully we can work that out in the long run. So if you notice any problems, please let us know. They're probably related to something. We have new API for trick modes. Trick modes means if you do fast forward playback or reverse playback, things like that. If you do double speed, that's usually fine. If you do quadruple speed, okay. But at some point, if you do 32 times speed, you have a problem because your computer just can't keep up decoding the stream at that speed. It's just too much. And on an embedded system, it's even worse, of course. So there are various approaches. You want to skip some frames. You just want to decode keyframes or things like that. Maybe you want to fast forward, skip keyframes, but not decode any audio. And we can do all that now. So if you do a seek in GStreamer, you can specify some flags, and you can say, well, do that, only render keyframes. We have to implement that everywhere yet. I mean, it's not implemented everywhere, but at least in Qt Demux and in the libav codec wrapper works already now. So it's all there now, and it should handle quite a lot of use cases. It's quite nice. Then we have a native Wayland video sync, which is non-GL based. For most cases, you probably just want to use OpenGL, but maybe if you have an embedded system or you have a very well-defined environment, then maybe that's better. The video for Linux source is what gets the stream out of your webcam into your application. Cheese or something like that has seen loads of improvement. Bug fixes around drivers, but also feature improvements. I think you can renegotiate the performance and the size on the fly now without stopping and restarting. In general, we had lots of bugs related to negotiation and renegotiation, so those should be fixed now, and that should hopefully work better. Some stats. I'm not going to read all of these out, but we have loads of bugs. I think we're buggier than evolution. Yeah. Well, maybe it's not true, but anyway, so loads of bugs fixed, loads of bugs opened. We have way too much bugs. We're drowning in bugs. I mean, we're kind of coping, but we need to do something about that. And help is always welcome. Loads of things in GStreamer are really quite easy to do. So it's usually harder to find something that you want to work on that you can actually approach without too much hassle. It's harder to identify something than to actually do it if you're reasonably experienced developer. So if you always wanted to hack on GStreamer, do some bug fixes, you might be able to find something for you. Some more stats. 220 contributors. 50 more than last period, that's nice.
How are you measuring contributors?
I think just unique emails. I don't know, did you filter by the same names? Yeah, I mean...
That's still
yeah, I mean, I don't say, most people who contribute just use one email address. There may be like 5 who use varying ones, but yeah, loads of commits. Fewer commits than last year. But almost 75,000 lines of new code. It's quite amazing.
How many commits are patches? I mean, do you get a lot of patches? Or do people mostly attach it to your bug tracker, or?
Well, external commits, I would say, I don't know, 50-50 maybe. I mean, most core contributors, they just push stuff unless they explicitly want review. So we don't have a policy where every commit has to be reviewed. I think it's been working for us so far. I mean, people will read the commits, and if they think it looks dodgy, then they'll say something. But otherwise, the proof is in the pudding. And most core contributors will just push their stuff, and external people will, or new API will go through Bugzilla as well. But I don't know if that answered your question. But it's about 50-50.
I'm just wondering about your process. Seems pretty open.
Right, the future. What's next? Yeah, so we have a new tracing system. I mean, I don't know if you've ever looked at a GST debug log. So GStreamer logs lots of stuff. Yeah, so you can set a very high log level, and if you play back a movie or something, you will quickly accumulate, gigabytes of logging data if you want to. And so I mean, yeah, it usually gives you loads of information if you want to find some bugs, but you actually have to find the information as well. And that works quite well for some things, but it doesn't work so well for other things. Sometimes you want to measure something. So we have a new tracing subsystem, which is going to land in the next cycle after 1.6, hopefully, and that should give us hooks into GStreamer, which should allow us to provide much better debugging applications that go beyond just, well, look at the debug log, or send us a debug log. So, yeah, so there will actually be a lightning talk later from one of the Google Summer of Code interns. He's hacking on stuff like pipeline debugging, and maybe you can see a little demo there even. So there's lightning talks later tonight. You can also provide a debug log viewer based on top of that. I mean, my personal sort of goal is that we have like some kind of application where you can even like on a remote machine just pop off the pipeline. You can zoom into bits and say, well, maybe logging there and there on the fly. It just gives you the bits, and hopefully it can do additional things as well, like measure sort of latency, where are delays in the pipeline and stuff like that. So it's going to be a long way to get there, but the basic tools are going to land soon, hopefully. Yeah, we have more work to do on the continuous integration. It's an ongoing process. More convenient APIs. So there's something where we've been lacking, especially for the playback side. We have this sort of element called Playbin, which is not, I mean, you kind of give it a URI and it just does stuff for you, which is nice enough, but I mean, it's still not really a nice API. I mean, people have been using Flutter GST just because the API is kind of easier if you want to select subtype streams or something like that. So that's where GST Player comes in. It provides a much nicer, high-level API to Playbin. Other than that, I don't know if there's anything in particular you've always wanted in terms of high-level API. Let us know. Yeah, maybe. We're discussing moving. Well, currently our bugs are maintained in GNOME Bugzilla, but our Git repository is on Free Desktop, and well, that caused some confusion because Free Desktop also has a Bugzilla, but it's very ugly. We don't use that. Also, historically, it was. I mean, historically, almost all the GStreamer using applications were GNOME-based. So it was nice to just move bugs around from application to GStreamer back, of course. So it was our fault. So anyway, we're considering moving to Fabricator now because there are lots of nice little features it provides. Bugzilla sort of, I mean, it kind of works, but I don't know. It works for me, but I might just have stop on something. Our website needs an overhaul. It's not great. We need better content. We need more tutorials. We need better documentation. Things like that. It's always an article list. One day we'll get around to it. In terms of features, I still have a few minutes. Yeah, trick mode support. We need to implement that in more places. Also in the adaptive streaming side, Dash and HLS. In HLS, it works sort of already. I think Dash is still missing. We can play back Dash and HLS streams really nicely, but we don't really have a way to serve them. So we want to run the server. You can serve an HLS stream. There's an HLS sync, but it's very basic. It kind of works for one very particular use case. But the the dash path that's still missing. It's in Bugzilla somewhere, so we need to flash that out. There are still some cross-platform improvements. The Windows support is lacking solely behind because we're all Linux hackers. And those who aren't are usually also ex people. So, but Android 0.copy decoding is going to land soon. Possibly we might be thinking about decode bin 3. I mean, currently we have a decode bin is like a little plugin. It's a step lower than playbin. So playbin does everything for you. It sort of decodes, and then it does the stream selection, which of the many subtitles you want to see, which audio track, etc. And then it renders it, and it does whatnot. I mean, it does everything basically you need in a movie player or an audio player. Decode bin is a bit lower level. It basically just decodes and gives you a bunch of encoded streams, and then you can decide what to do with that. If you want to re-encode it or stream it out or save it somewhere or show it, or, up to you. But it's not as optimal as it could be. So we might be improving that so that because it's much more common these days that the stream configuration changes on the fly, like all these adaptive streaming cases or MPEG-TS, for example. So it would be nice if you can just reuse existing decoding chains. And also on the application side, it's much nicer if you don't have to worry about hooking up new paths all the time, but you can just, nothing changes for you. So hopefully, there are some thoughts going on, so that we can do that. Something we also need still is better metadata extraction. We have Discoverer, which is a little helper API to sort of discover a file, it gives you the screens, etc., and the resolution, caps, and tags, and whatnot, which works for most people. It's not perfect. It could be improved a lot. And we have lots of third-party plugins which we should move into GStreamer at some point, like an Android camera source, that the Corrento endpoint, WebRTC endpoint that Sebastian has mentioned, so you can easily write WebRTC applications. Building the whole Corrento stuff is a little bit painful, so we'll just move that into GStreamer. That would be nice. Camera, yeah, we want to. It's currently in DC plugins bad, but we should really do it. But bad is a problem because not all just package it. We just move it into good or base or something. But it's always there. All right, I think we have about 7 minutes for questions. Thanks very much. Just 1 second. Yes, there is a GStreamer conference. It's 2 days, full packed with talks and a social event. It's in Dublin, and it's in October. You should join us.
Is that the first year's GStreamer conference?
No, it's the 6th GStreamer conference, actually. Yeah.
Could you explain a little bit more?
Sorry.
Could you explain a little?
It's on the mute. Unmute.
Could you explain a little bit more about embedding GStreamer in the Chromium project? Both, what are the intentions? Is it sort of, is this widely supported by Google going forward? Or are you worried about API breakage or things like that? Sounds very exciting.
So I didn't work on that personally, but I think the main reason for that is that it's much easier on embedded Linux platforms to use the hardware codecs, because usually you have some way of integration with GStreamer. And well, also, in my opinion, the stability and features that are provided by GStreamer are much more than what the native backend of Chromium provides. So I think over time it might also improve the media support in there, but I don't think Google's ever going to support it. It's LGPL, that's probably enough for Google to not support it. But last time I heard the plans were to at least merge it into the Chromium repository. It's just going to be unofficial.
Any more questions?
Hello. Nguyen, and I have a question about, I forgot the name of that project, but Pulse Video? Yes. The Kinos, yes. I really wonder how do you share the camera surface to other process? So do you using the, so it looks like you should pass bitmap via file descriptor. So it means to to composite that content, we should download the text, the bitmap from texture, and also the bitmap from the camera should be read from the hardware to CPU, whatever chips that.
I don't think it's sort of as efficient as it could be theoretically if you don't have any, but in this case you're passing it through processes and stuff, so you have to do some copying, but I think it's backed by a file descriptor. It's basically an mmapped file,
Yes,
which you
mmapped
and then you
file.
pass file descriptors around. I can. Do you want to comment on that?
Yeah, so theoretically you pass the bitmap
Yes.
as a file descriptor. Given the current state of affairs, an mmapped file is the safest way to do that. Maybe in the future, when all video for Linux APIs can give you a file descriptor directly, you could pass that around. If memfd is an option, then we can use that one.
So there is no way to avoid the copy operation, the hashing the bitmap, hashing the camera surface for that, right?
Not reliably yet.
Yes.
But we hope to be able to do that.
Yes, that's
Well,
a
at some
great
point,
data.
at some point you probably could do that with the enable, if your hardware supports that.
Yeah.
Yeah,
If you can get the file descriptor from Video for Linux, that's it. The MABUF or any other one.
Any more questions?
One other question. So GStreamer API is now stabilized, right?
Yes.
Yeah,
Well,
okay.
it's always been stabilized, but
I believe that, right?
no, we don't try to. We always add new things, but we don't break stuff. And if we break stuff, we had the old 010 series, which was compatible, right? So if we break stuff, we don't break it, we just make a new version, and then everything. It's basically like a new library. So, we don't. Sometimes we might break something accidentally, but in general, we only add new API.
So when is GStreamer 2.0 coming out?
I don't think we have a need for that yet. So, but at some point, the version numbers get too high, then we pull in Linux. Right. Thanks very much. Thank you very much.
Jag tycker det var 50 så var det bra. You will be shared by the developers of the top.